Okay, good afternoon. We're going to solve system of equations by graphing. And what we want to keep in mind is that we want to make sure both equations are in slope-intercept form. Okay, and if you look at this one, okay, y equals, this looks like the slope-intercept form because your 1 over 7 is going to be your slope, and then your y-intercept is going to be your 2. Okay, so remember, this is your slope, okay? And that's going to equal 1 over 7. And remember that this is rise over run. And rise could be up or down. Run could be right or left. Okay? And the signs to associate up would be positive, down is negative, right is positive, and left is negative. Okay? So, and then this here, okay, is your slope-intercept form. Your intercept, your y-intercept. So your y-intercept is going to be, B is going to be your y-intercept. So for this particular equation, that's going to equal 2. And then when you write it in coordinate form, it should be 0, 2. Because you have your x, y. In order to be a y-intercept, then the 0 coordinate must be at the origin, and then you're either going up or down the y-axis. Okay? So just a little brief introduction or summary of how to read y-intercept form. Okay? So again, that is called your y-intercept, your slope intercept form. All right. So that equation's all set. It's already in the right form. Once you have your y-intercept and slope, then you can go ahead and start graphing the equation, which I'll show you on the next slide. Okay. So this other equation is in standard form. Okay. And standard form is basically, ax plus by equals c, okay? And that's going to be in standard form. So we're going to have to solve for y, okay? So when we go from standard form to slope-intercept form, okay, let me just rewrite that a little bit neater. My pen keeps slipping, so it's, here we go. In order to go from standard form to slope-intercept form, then your goal is to solve for y, okay? So we can do that when we have 7y minus x equals negative 63. We can go ahead and solve for y by starting with x, adding x on both sides so that the x variable cancels. Then you're just left with 7y equals, and then instead of writing minus 63 plus x, I'm just going to write x minus 63 so it's in the right order. Okay, it's a little bit easier to read. And now we're going to go ahead and divide everything by 7. Okay, so the coefficients of 7 cancel. Then you're just left with y equals. Now remember there's an imaginary 1 here. So when we write that, it's just 1 over 7x. And then 63 divided by 7 is 9. All right? Okay, so now we want to graph these two equations, okay? So we want to graph this one, and then we want to graph this one, okay? So these are our two system of equations, okay? So In our next slide, okay, so on the next slide, we're going to graph these two equations, okay? So the first one, okay, that I'm going to graph, we'll just call, this is the one that was already in slope-intercept form, 1/7x plus 2. Remember that one was already given? And then the other one that we converted from standard to slope-intercept form was this. All right? So when we do this graph, remember that we need the y and x axis. Now, so we can go ahead and do this very carefully. All right. Okay. So this is your y-axis and this is your x-axis. And I'm going to create my own scale because the other one didn't have the right scale. So let's see here. Okay, we think we should be good. All right, so this is great. All right, so now let's go ahead and do the first one. All right, 1/7 x plus 2. So remember that for the first equation, okay, okay, your slope is 1/7, okay? So your rise is up 1 unit, okay? You're going to go up 1 unit and then 7 to the right because both numbers are positive. Does that make sense? Okay? And then your y-intercept is going to be written as 0, positive 2 because this is your x and that's your y, okay? Y-intercept means it crosses the y-axis at 2 while x is 0, and that always has to be the case, right? X always has to be 0. So the first thing that you want to graph is your y-intercept. So when we do that, okay, we got 1, 2, so it's right over here. Okay, we go up 2 units. Each little grid is 1 unit, so we'll go up 2 units, and that's your first point. And then from that point, we go up 1, okay? We go up 1 and then over 7. So let me count this, okay? 1, 2, 3, 4, 5, 6, 7. So right there would be your second point. And if you want to reverse it, you can go down 1, 1, 2, 3, 4, 5, 6, 7. This would be your other point. And that's why the run can be negative, because you can go backwards and get the points to the left if you need to. And that'll give you a real accurate graph. And then now you can just go ahead and plot it. Okay? So, again, this is always a little challenging when you do it freehand. All right, so, and then now that would be your graph. Okay. And try to get it as straight as I could, okay? But you guys get the idea that that's how you graph a line. So that's going to be called y1, okay? All right, so the other equation, okay, the y-intercept is -9. So remember your slope is still 1/7, and then your y-intercept is 0, -9. Okay, that's your x and that's your y. All right. So let's plot the y-intercept first, okay? So we start at the origin, and then we go 1, 2, 3, 4, wait a minute, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's like way down here. Okay? And then the slope is going to be the same. We go up 1 and then to the right 7. So 1, 2, 3, 4, 5, 6, 7. That would be right there. Okay, and then you can reverse it, go down 1 from the y-intercept and left 7. 1, 2, 3, 4, 5, 6, 7. And as you can see, okay, a little bit of a freehand, but the lines should be parallel. You know, if they were perfectly done, they would be parallel. Okay, so in order for this to happen, you notice the slopes are identical, 1 over 7, 1 over 7. Okay, so these two lines are parallel. Okay, so these are parallel lines. All right. And what that means is that they have the same slope. Okay? The first equation had 1 over 7, and the second equation had a slope of 1 over 7. Okay? So that means these lines are never touching each other. They're parallel. Oops, did I erase the same slope? Sorry about that. Same slope. Okay? Okay, so let's do another example. All right. I'm just going to write them off to the side, okay? That way, if we need to do any algebra, we can just write them side by side. All right. Now, both of these are in standard form. That means that the y is not solved, okay? So, clearly, we need to solve both of these for y. I'm going to go ahead and start with the one on the left, all right? And I'm going to move the 9x over by adding it to both sides. And that way, this cancels. Then you're just left with y on the left. Instead of writing 1 plus 9x, I'm going to write 9x plus 1. And you notice that one's already in slope-intercept form. That's all I had to do was move the 9 over, and that was it. Okay? And then now for this one, for the second one, you notice the y has the 8. So that's 8 times y. So the opposite of multiplication is division. And I'm going to divide everything by 8. Okay? So when you do that, 70, well, first of all, the 8's cancel, and then you're just left with y equals 72 divided by 8 should give me 9, 9x. And then 8 divided by 8 is 1. And that makes the equation very simple. So remember, these two right here, okay, we want to graph. All right? So let's do that on the next slide. All right? So the equations that we want to graph, okay, the very first one was y equals 9x plus 1. And you notice that the second one was also 9x plus 1. So we had two equations that we're going to graph. Okay, and you notice that those are identical equations. Okay, so when you graph them, it's basically the same line, and that's going to tell, this should be y2. Okay, this is going to tell me something here. Okay, so if I graph the first one, right? And they both have a slope of 1. They both have a y-intercept of 1, okay, which is going to be here. That's my first point, 0. Or when x is 0, y is 1. And then from that point, the slope, okay, so remember, they both have a slope of 9 over 1. Or just 9. And then they both have a y-intercept of 0, 1. Because this is your x and this is your y. So basically, If they both have a y-intercept of 0, 1, well, here you go. There's your y-intercept in that blue dot. And then from that y-intercept, you graph your slope. Okay, you don't start back at the origin. You start at the slope, and then you go up 9 units. So let's figure this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 1, which would be right over there. Sorry. Right over there. All right, and we have our 2 points, and we connect them, and that's going to be our slope. So our slope is going to be extremely steep here. Okay, so okay, and we just go ahead and continue that like that. Sorry, it's a little bit off, but you guys get the general idea that it's almost a vertical line. So there's no need to graph the other one because the other one's the same. So both of these lines are going to be on top of each other. This is the graph. All right. This is going to be the graph, and I'll tell you, this is driving me crazy. Let's go ahead and correct that. Get a little better. All right. Okay. So that would be the line, that would be the graph for both of those lines. And what happens is the lines are identical. So we'll write that here. So we have identical lines. And anytime you see this special situation, that's basically going to tell us that there are infinite, okay, there's an infinite number of solutions. All right? And that only occurs when both lines overlap each other. Okay? And if we go back to the previous slide, actually 2 slides, remember the very first example we did? We said the lines are parallel. When you see this situation, then parallel lines will always have no solution. Okay? So parallel lines will have no solution at all. Okay? So there'll be no solution. Because the lines never touch each other. There's no intercept. So we don't have an intercept because the lines they never cross each other. They never intercept. So there can never be a solution to these equations. Okay? Unlike this example where the lines share the same line, they're on top of each other, then that means you will have infinitely many solutions. So you can plug in, there's many different points. There's an infinite number of points on this line because the line goes forever and ever, right, in both directions, in the positive infinity direction, okay, and in the negative infinity direction. So there's infinitely many points on this line, okay. If they're parallel, then that'll never happen. They don't have any intersecting points, okay, so they can never be a solution. All right, so if you look at this situation, okay, and I want you to graph these, y equals minus x plus 5, and then y equals x minus 3. Now you notice that both of them are already in slope-intercept form. So that means that you do not have to solve anything for y. The y is already there. You see that? Y equals. So the good news is that you can just start graphing these immediately, okay? So let's take a look at that on the next slide. Okay. And we're going to graph our 2 equations that we were given. Remember, they were y equals minus x plus 5. So we'll call that y1. And then my second equation y2 we will call x minus 3. Doesn't matter which one you call the first or the second. I like to do it so I can refer to y1, y2. It's a little bit easier. Okay, and you notice that the slope here is equal to a minus 1 over 1. There's an invisible coefficient of negative 1 next to the x, and it's also written over 1. So that means my slope is we're going down 1 unit and then right 1 unit. All right? And then my y-intercept is going to be 0, 5. Okay? And then here, my slope is going to be 1 over 1. So I'm going up 1 unit and then right 1 unit. And then my y-intercept is 0, negative 3. So I have more than enough information here. Let's go ahead and graph the first one. So we have 0, 5. So that's my first point, which is right about here. And then my slope is going to be, so down 1 over 1, down 1 over 1. I'm just going to kind of skip it here. Down 1 over 1. You see that? Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So that would be my line. Okay, so if I connect these points, okay, just kind of go like that, and that is going to be your y1. Okay? And then my other equation we said was 0, 3. Well, that's down here. Let's do that in red. 0, that's right here. And my slope, okay. Oop, I think I made an error. I went in the wrong direction. So I apologize. I you know, sometimes when you do enough of these problems, you get a little bit tired. So I need to erase this. Okay, it's an easy fix. It's no problem. Let me just go ahead and okay, I'll just rewrite that as 0, negative 3, and then like that. So we said that the first line, the slope-intercept, is still going to be at 5 right there. But when I went down, I should have went to the right. I accidentally made a mistake. See, it just shows you that we all make mistakes. But as long as we fix it, and that's all that matters. So we go down 1 and then right 1. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Down 1, right 1, down 1, right 1. And now we have the right graph. Okay? And that's what we want. Perfect. Okay? So then you just go ahead and connect them as best you can. Okay? And now we can proceed with the red one. 0, 3, negative 3 is your y-intercept down here, and then we go up 1 over 1, up 1. I am so sorry. I'm not confusing anybody here. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to make this a little bit bigger. Up 1 over 1. So what happens to these lines? Well, they clearly do what? They intercept each other. Okay? And there's a point of intersection here. All right? So they clearly intersect at a point. And that point, we'll just put it in green so it's easier to see, is going to be, we read it, so the x coordinate is going to be 4, and then the y coordinate is 1, so it's 4, 1. And that means my x is going to be 4, and my y value is going to be 1. That's what it literally means. So We'll write that over here. X is going to equal 4, and then y is going to equal 1. And that is the solution for these equations. And to verify, we can choose one of them. Okay, we can go ahead and choose one of them. And we can check it. We can actually check this to see if it is truly a solution, right? So remember, one of the equations is that, well, if x is 4, all right, if our point is 4 comma 1, then let's check it. This is my x and this is my y. So let's check it, right? Y is going to be 1, and then we're plugging in 4 for x. We're going to use parentheses to separate that minus sign. Okay, so now it becomes minus 4 plus 5, and then negative 4 plus 5 is 1. Does 1 equal 1? Yes. Okay, so therefore this part is a solution, okay? So we have our solution. Okay, so this is our solution. And then it'll work for the other one in red if you plug it in. Okay, because, you know, y is 1, so 4 minus 3 is 1, so we know it's going to work. Okay, so plug it in here, and then you know that it's going to work. Okay, so it is definitely a solution. So the three possibilities that you're going to get, okay, you're going to get parallel lines. If you graph two lines and they're parallel, then they do not have any solutions to them. If you graph two lines and they're on top of each other, literally, that means they have an infinitely many solutions, infinite number of solutions. And if you graph two lines and you get an intersection, okay, that means you could only have one solution for that system. Okay? And in this case, in the very last one we did, was 4 comma 1. Your x is 4 and your y value is 1. And you can check by plugging in those values into both of the system of equations that were given to you and see if they equal out on both sides. See if they give you equal quantities. Okay? And that will tell you if you have the right solution. Okay? But if you graphed it correctly, then you should be good to go. You can always verify this on a graphing calculator if needed. All right? Okay, I hope this video was helpful to you. And thank you so much for watching. And I'll see you around.